So Chris, for oxidation reduction, last time what we had done was we had understood what are oxidation, how to calculate oxidation numbers. Now oxidation numbers basically help us to understand redox reaction in a better way. See, we have one of the standard way in which we understand the definition of oxidation and reduction is one is oxidation is in terms of oxygen. So if I talk about oxidation, what I'll say is that addition of oxygen would be called as oxidation. And similarly, when I say reduction, so reduction would be the subtraction of oxygen. So this is oxidation reduction is being explained in terms of oxygen. Are we clear till here?
Yes, sir.
Of course, last time what we understood was we understood how to the rules regarding oxidation, how to find the oxidation numbers, etc. So basically, this is what we had discussed last time: oxidation reduction using numbers, rules, practice, problem, class 11. Now there is another detailed lecture which you will find here: how to find oxidation numbers. Do you see the second lecture?
Yes, sir.
I'll send you this playlist. Just have a look at whenever you have time. Just have a look at this second playlist also.
Okay, sir.
So, what we want to understand, basically, what we want to emphasize now is that we want to understand redox reactions in terms of charge, redox. So, like what we were discussing last time is oil rig. Oxidation is loss of electrons. Oxidation is loss of electrons, and reduction is gain of electrons. Are we clear about that?
Yes, sir.
So oxidation is loss of electrons. This definition of oxidation and reduction is in terms of loss and gain of electrons. Are we clear?
Yes, sir.
Now, compared to this definition of oxidation reduction, which is in terms of oxygen, there is another definition we had discussed in terms of hydrogen also. So compared to this definition of oxidation reduction in terms of oxidation or hydrogen, this definition which talks about gain and loss of electron, this is a far better definition of redox reactions. Are we clear till here?
Yes, sir.
Now I'll give you a few examples, and we need to understand these examples well for a simple reason that when we'll be doing this chapter, reactions at electrodes, when we'll be doing this principle of electrolysis, two more uses of electrolysis, again we will be using all this stuff that we have discussed in oxidation reduction. Are we clear?
Yes, sir.
So at that time we'll have to understand the loss and gain of electrons. So for example, say for example I'm discussing electrolysis and I'm saying that oxidation takes place at anode. Say for example I say that. So you'll have to understand that when I say oxidation is happening at anode, what exactly is happening at anode? Is it making some sense?
Yes, sir.
Okay. So now this is how you'll have to understand when we are doing electrolysis. So we have defined oxidation as loss of electrons. So loss of electrons, how does the loss of electrons look like? So for example, magnesium. Now as a metal, it has lost 2 electrons. So when a reaction is written like this, basically how we can read this reaction is that Mg gets converted into Mg2 plus 2 electrons, and these 2 electrons are considered to be lost from magnesium. Chris, is it making sense or not?
Yes, sir.
So whenever, just remember this format. Whenever a reaction is written like this, basically what we are saying is that the entity on the left hand side has lost 2 electrons. Is it making sense?
Yes, sir.
And we should be very clear. Basically, I'll be sending you this PDF, and what I'll suggest is just copy this PDF so that you understand how these reactions in terms of loss and gain of electrons are written.
Yes.
Understood my point? let us look at the second reaction. So, for example, in second reaction, what is happening is that there are two ions, basically two anions of chlorine, which lose two electrons and form chlorine gas. Is it making sense?
Yes, sir.
Basically, I have two negatively charged ions of chlorine, can be called as chloride ion also. Now, if you see closely, there are two such ions, and both these ions have lost one electron each, and in total they have lost two electrons. Once they have lost the charge, they form chlorine gas. Cl2 is chlorine gas. Are we okay till here?
Yes, sir.
We should be very clear about these reactions because day in day out in electrolysis we will be using this. Let us look at this. So here what is happening is that water has broken down into these four cations of hydrogen. All four have positive charge. Oxygen gas plus 4 electrons. So these 4 plus 4 charge is balanced by this 4 negative charge, and that is why there is a zero charge here. So on the left hand side there is zero charge, and on the right hand side also there is a net zero charge. Chris, is it making sense or not?
Yes.
Because these are a bit difficult things, but once we start doing electrolysis this will start making more sense. But because we were discussing redox reaction, so I wanted to discuss this also, so that we can understand the half reactions. These are called half reactions. You will understand what are called half reactions, don't worry. So again, if we look at this ion, this is a big ion. Let us just see what is happening to the charge. If you look at the charge, there was a -4 electron charge here. Then the entity that is formed is of -3 charge, and we see one electron is being lost. Is it making sense?
Yes, sir.
Now, in all these four cases, the first case, the second case, the third case, as well as the fourth case, what you will see is electrons being lost. Do you see this?
Yes, sir.
The electrons are being lost, and because electrons are being lost, that is why oxidation is loss of electrons. So, oxidation is taking place in all these four reactions. Is it making sense?
Yes, sir. Sir, I wanted
Yeah,
to share something. My
yeah.
teacher taught him as a different thing of oil rig.
Okay.
So she said that when electrons are on the reactant side, the, they are they are they are undergoing a reduction reaction,
See,
and when
yeah, yeah. I've
and
understood
when
what you. Yeah, and I've understood what you are saying. So, for example, another way of writing this reaction is there are times when they write like this also. Mg minus 2 electrons gives Mg2 plus. Have you understood what I've said?
yes, so
So
this is
both,
undergoing
yeah, yeah, yeah.
reaction.
Both of these are one and the same thing.
Yes,
Basically, we are just using the we are using simple algebra rather than, if you are comfortable with this you can like write like this. I am more comfortable with this, but we are using the basic rules of algebra. I can write the same equation as mg2 plus 2 electron also. So if you see the sign, this negative is positive on the right hand side. Is it making sense?
yes, sir.
So these are one and the same thing. There are These are the two ways in which reactions are written. I usually write reactions like this. uh, there are textbook who write reactions like this, but we should understand that both of these are one and the same thing. Are we okay till here?
Yes, sir.
Okay. So reduction is the gain of electrons. Now when I write gain of electrons, this is the way I like to write that this party, this entity, this cation, when it got two electrons, so this was plus 4 charge, and when two electrons were added to it, it became plus 2 charge. Do you see this?
Yes, sir.
So similarly, this entity had no charge, zero charge. When one electron was added, it became minus 1. Do you see this?
Yes, sir.
This party, this client, this entity had zero charge, but when two electrons were added to it, if you see, the balance of charge on both sides should remain the same. If you see on this side, you have two entities, you have two anions with -1 charge each, and that is why there is a -2 charge on right hand side and there is a -2 charge on the left hand side. Is it making sense, Chris?
Yes, sir.
So now this is how I like to write that this entity has received 2 electrons. Reduction is gain of electrons. So this entity is getting reduced. This entity is getting reduced. This entity is getting reduced. Is it making sense, Chris?
Yes.
So whatever format you want, if you want to follow the school format, that is fine. If you want to use this format, this is fine. There is absolutely no difference between these two. This is how I like to write oxidation, that oxidation is loss of electrons. So how I present loss of electron is that Mg has lost 2 electrons. But the important thing that we need to understand is, the important thing that we need to understand is that if we try to see this, if we try to see this, if we try to see this in terms of oxidation number, because that is where what we were discussing last time, the oxidation number here is 0, but here it is +2. So the definition that I want to use is that whenever oxidation number of an entity, of an ion, of a whatever, of an element increases, then oxidation is taking place. And whenever the oxidation of an entity reduces, then reduction is taking place. Chris, is it making sense?
Yes.
So basically, if you look at just 2 examples, you will understand what I am saying. So for example, look at this magnesium. This magnesium has an oxidation number of 0 on left hand side. It is converted into +2. Its oxidation number has increased. That is why here magnesium is getting oxidized. Is it making sense?
Yes, sir.
Here, if you look at tin is a +4, but when 2 electrons were added, its oxidation number has decreased. When its oxidation number has decreased, it is an example of reduction. Are we clear?
Yes. Yes, sir.
So what we are trying to understand is, Chris, for the last, I think 2-3 lectures now. Yeah, I think 2 lectures now. So we started with the understanding oxidation and reduction.
Yes.
Oxidation and reduction in terms of we started understanding oxidation reduction in terms of oxygen and hydrogen. Then in the
Yes.
second lecture we started understanding, we understood what are
Electrons.
oxidation. We understood what is oxidation number, and using oxidation number we were able to analyze the redox reactions. And last time when we were finishing the lecture, we started understanding redox reactions in terms of electrons, and this time will be more focused how the electrons loss and gain can be called oxidation reduction and vice versa. Is it making sense?
Yes, sir.
So I'll show you a few examples. So for example, the first reaction here, if you see Pb, it has +2 charge. The oxidation number is decreasing. When the oxidation number decreases, it is an example of reduction. Is it making sense?
Yes, sir.
Hydrogen has 0 oxidation number. It becomes +1. So oxidation number has increased. Because oxidation number has increased, it is an example of oxidation. Is it making sense?
Yes, sir.
But if you observe oxygen, it was -2 here and -2 here. Any doubt?
No, sir.
And if you see the rules of oxidation numbers, the rules of oxidation numbers still carry. Oxygen is given oxidation number usually -2. Here hydrogen is formed in nature, so that is why the oxidation number of hydrogen is 0 here. Again, lead is 0 because it is in the elemental state, it is in its natural state, that is why it is 0. And here if you see, hydrogen is attached to a non-metal, that is why its oxidation number is +1. and oxygen still is minus 2. Is it making sense, Chris?
Yes, sir.
Let us look at a simpler example. So ZnO plus C, elemental carbon, so that is why oxidation number is 0. Oxidation is minus 2, zinc is plus 2. Now here this plus 2 changes into 0. This is one way of looking at this, is that this is a reduction in oxidation number. Reduction in oxidation number is actually reduction, so that is why it is reduction. Here,
Yes.
if I look at carbon, carbon oxidation number on left is 0, but on the right is plus 2. This is increase of oxidation number. Increase of oxidation number is oxidation. That is why carbon is getting oxidized. But if you look at oxygen, oxygen, nothing is taking place to oxygen. It was minus 2 here, minus 2 here. Any doubt?
No, sir.
Okay. So, see, these two are okay examples, but if you look closely at this example, this P4 plus O2, then one thing that we were discussing in oxidation number, here phosphorus 4, this is it in its elemental state. This is how it is formed in nature. That is why oxidation number of 0 is given here. Here oxidation number, oxygen is how it is formed in nature. That is why 0 is there. But if you look at the right hand side, oxygen still has oxidation number minus 2, and to calculate the oxidation number of phosphorus, we have to do that algebra that we had discussed last time. So phosphorus has got an oxidation number of plus 5. Now from 0 it has become plus 5, the oxidation number has increased, that is why oxidation is happening. But for oxygen, the oxidation number has decreased from 0 to minus 2, that is why reduction is taking place. Any doubt, Chris?
No, sir.
Let me pick another simple example. So CO2 plus H2 gives carbon monoxide plus water. Here also if you see, so carbon, oxygen has a oxidation number of minus 2. So carbon will have to have a oxidation number of plus 4. So carbon from plus 4 on the left hand side changes into carbon of plus 2 on the right hand side. The oxidation number is decreasing. But oxygen, if you see, oxidation minus 2, minus 2, minus 2. The oxidation number is the same. But for hydrogen, if you see, hydrogen has gone from 0 to plus 1. So the oxidation number has increased. That is why oxidation is happening. Chris, is it making sense or not?
Yes, sir.
So, using the oxidation numbers, and that is why we had spent last lecture understanding the rules of how to find oxidation numbers. So using this concept of oxidation numbers, because this is a more powerful tool to understand redox reaction. So using the concept of oxidation number, I can analyze redox reactions. Chris, is it making sense?
Yes.
See, Chris, what I'll suggest is, I will send this PDF to you. Just copy this PDF. Right now it won't be making much of sense to you, maybe. But we will be using this, whatever we have discussed today, to understand these electrolysis reaction. Is it making sense?
Yes, sir.
Just give me 1 minute. I'll show you how this chapter looks like. Maybe you will get a idea what I'm talking about. So do you see this
Yes.
Ag plus electron? So if you would see that this is basically oxidation or reduction.
So this one is a reduction.
Why reduction?
So reduction because electrons are given out. Sorry, sir. Sorry, sir. This is oxidation because electrons are given out, so it becomes positively charged.
Have you understood now?
Yes,
So
sir.
that is why it, if you look at this reaction, this electron which is being lost is written on the right side. So the electron is lost. When the electron is lost, This is oxidation. Have you understood? Similarly, if you look at this reaction, this entity is gaining electron. Gain of electron is reduction. So here a reduction is taking place. Chris, is it making sense?
Yes, sir.
And another way of looking at this is this oxidation number 0 is being converted into +1. So oxidation number is increasing. That is why this is oxidation. Here in the second reaction, if you look, this +1 is being converted into 0. Loss of oxidation number is happening. That is why this example is an example of reduction. Mr. Chris, is it making sense?
Yes.
So this chapter electrolysis, when we come to electrolysis, I think this would be the next reaction next chapter they might be discussing.